Hi everyone, welcome to G World of Academic Physics. Already Model 1 and Model 2 we have discussed. Today we will discuss the Model 3, the basic models of electrostatic. Look at these questions. Two charges Q and 4Q at a distance r apart. The question is asking where the third charge is placed so that the third charge in equilibrium. So this is charge Q, this is 4Q, and this Q and 4Q at a distance r apart. Question is asking where I will place the charge so that the third charge will be in equilibrium. So I just consider any random point in this line. I placed a charge here. I don't know at what distance it will be exist. I said this is suppose x distance. I placed a charge q and I need to see at what distance this charge in equilibrium. If this distance is x, I said this distance is r minus x. If this charge is in equilibrium, I must find the net force on this charge, which is equals to 0. If net force on this charge is 0, I can say force due to this charge on this and force due to this charge on this must be equal. So using the Coulomb's law, I can write force due to this charge Q. It will be like this: K Q, capital Q, upon x square must be equals to this one, K Q 4Q upon r minus x whole square. If you see carefully, this K cancel, 1Q has cancelled, and we are getting the result. This is Q, this is 4Q. So this Q and this Q also cancel. So 1 upon x square equals to 4 upon r minus x whole square. So 4x square equals to r minus x whole square. This is 2x equals to r minus x, and we are getting the result that r equals to 3x. So x equals to r by 3. So exactly at a distance r by 3, it means the scenario I can say where the third charge will be placed exactly at a distance of r by 3 from the smaller magnitude charge, and to the larger magnitude charge it will be at a distance of 2 r by 3. Yes. Now look at the second questions. Two different polarity of the charges. This charge is negative, this charge is positive at a distance r apart. Going to the question number B. So I will say this is minus q charge, this is 4q charge, and they are at a distance r apart, where I will place the third charge so that the third charge in equilibrium. If you observe carefully in these questions, the equilibrium point is always coming to the nearest to the smaller charge. If you carefully observe, the equilibrium point is coming at r by 3. It means exactly nearest to the smaller charge, always the equilibrium point will be arise. If you observe carefully, this charge, this is Q, it will repel like this, and this is 4Q, this is Q, and it will be repel like this. So definitely this point is the equilibrium point, and important point that will be on the checklist, that equilibrium point always nearest to the smaller charge. Using the same concept here, I have a probability here that equilibrium point, this is Q, this is 4Q. Sorry, this is Q and this is 4Q. Don't think that this is negative Q and this is positive 4Q, and always consider the magnitude of the charge. So I will prefer this is Q, this is 4Q, like this scenario, and this is the smaller magnitude of the charge. So it will always nearest to the smaller charges. But in the smaller charges also there will be two possibility. It can lies here or it can lies here. If you consider here, let's check. I will bring this Q, minus Q, this is plus Q. It will what? Attract. 4Q, this is Q, positive, it will repel. So in this point, the equilibrium point is not possible. So in this case, where the polarities are different, Now definitely the equilibrium point always nearest to the smaller charge, but that point exactly lies outside rather than here, because this is negative, this is positive, it will attract, positive repel. We cannot say this point the net force is 0, but look at this point, negative positive attract, for this one positive repel. That's why net force at this point, these two forces balance each other, that's why the net force is 0. As the point lies outside, we consider this distance as x, and this is what are already given in the questions. So at this point I will see the net force is 0, so force due to this charge on this equals to force due to this charge on this would be balanced. Now carefully observe, I will write, always write the magnitude of the forces. So K Q upon x square equals to what? K Q 4Q upon R plus X whole square. This is K Q cancel. I'll get 1 by upon x square equals to what? 4 upon R plus X whole square. So what are the things I'm getting? 4x square equals to R plus X whole square. I'll get 2x equals to R plus X, and I'll get the R value is what? I'll get the x value, I'll get the x value. This is x equals to R. It means, what the conclusion I concluded here, in this case, this is Q minus Q, this is 4Q, and the equilibrium point here it will exist nearest to the smaller charge, and this is at what distance? R distance, and this distance is also R in the questions, it is given. This is the equilibrium point. You can say this point P is the equilibrium point. So using this concept, one thing I concluded, always remember in your checklist that equilibrium point always nearest to the smaller charges. Equilibrium point always nearest to the smaller charges. If the two charges same polarity, means both the charges positive, then equilibrium point lies inside between the two charges and it is nearest to the smaller charges. If the polarities are different, minus Q, 4Q, the two different polarity, one is negative, another one is positive, then equilibrium point will lies outside, but it is nearest to the smaller charge, but it will not inside between the two charges, but it will lies outside of the two charges. I hope the scenario is pretty clear to everyone. Thank you everyone. Thank you for your watching.